Today's lesson is going to be on dependent and independent probability. A compound event is an event that contains one or more outcomes. Those outcomes can be considered either dependent or independent. So a dependent probability or outcome is the outcome of one event affects the probability of the other event. So for example, if you pull a marble from a bag and do not put the marble back, the next time you pull a marble, what is happening inside the bag has changed. Therefore, the second probability becomes dependent on what you did on the first probability. An independent probability means the outcome of one probability and what happens does not affect the other one. So for that marble example, if you pulled that marble out but then put it back into the bag, what's happening inside the bag has not changed at all. So those two events are considered independent of each other because what happens with one does not affect the other. So examples of dependent, independent. If you roll a number cube twice, what happens on the first roll does not have any effect on what happens on the second roll. So they would be considered independent of each other, and I'm just going to abbreviate. A marble is pulled from a bag and not replaced. Once you place that marble on the desk next to you, what happens next becomes dependent on what you did. You changed what's happening inside the bag. A number cube is rolled and a spinner is spun. When the number cube is rolled, it doesn't affect what happens on the spinner or vice versa. So those two events would be considered independent of each other. Two cards are drawn from a deck, one after the other, and the first one is replaced. So by replacing that card back into the deck, there are still 52 cards to pull from on the second probability, so they are independent of each other. So you have to think about what you do on the first one. Does it affect what can happen on the second one? When we have compound events, we use the multiplication property. So basically, you're going to find the probability for each event and multiply them together. This word "and" means to multiply. So here we have a bag of marbles. We've got the total over here on the left-hand side. You have 5 blue, 6 yellow, 11 red, 8 green. And we want to know what's the probability of pulling a yellow and then another yellow without replacing it. With replacement. So when you look at this, the probability of pulling a yellow is going to be 6 out of 30. Well, when you put that marble back, you still have a probability of pulling 6 out of 30. So what happened didn't change the second probability. So I'm going to use the multiplication property. So 6 times 6 is 36, 30 times 30 is 900, and I'm going to reduce it down. So to pull a yellow, replace it, pull another yellow is 1/25 is the probability. So now let's look at it without replacement. So we have that same bag of marbles. We're doing the yellow and the yellow, but without replacement. So the first one is that 6 out of 30. But then by not replacing the yellow, I no longer have 6 yellow, now I have 5 yellow, and I no longer have 30 marbles total, I have 29 marbles total. So that's where this 5/29 comes from. So you can see the second probability has been affected by what happened with the first one. I'm still going to use the multiplication property, so 6 times 5 is 30, and 30 times 29 is 870. Reduce it down, it is 1/29.